File designed by Salem and Yusuf to simplify the explanation for the listener. Matrix multiplication is an operation performed on two matrices to produce a new matrix. It is a fundamental operation in linear algebra and is widely used in various fields, including computer graphics, physics, and data analysis. For matrix multiplication to be defined, the number of columns in the first matrix must be equal to the number of rows in the second matrix. If matrix A has dimensions mxn, m rows and n columns, and matrix B has dimensions nxp, n rows and p columns, then the resulting matrix C will have dimensions mxp. The general formula for calculating the element at the ith row and jth column of the resulting matrix C is
A equals mxnb equals qxpn must equal q in this formula. A, mn, represents the element in the ith row and qth column of matrix A, and B, q, represents the element in the qth row and jth column of matrix B. The sum is taken over all values of k from 1 to n. To perform matrix multiplication, you would iterate over each element of the resulting matrix C and calculate its value using the formula mentioned above. The resulting matrix C will have the same number of rows as matrix A and the same number of columns as matrix B. It's worth noting that matrix multiplication is not commutative, meaning that in general, A asterisk B is not equal to B asterisk A. The order of multiplication matters, and the dimensions must be compatible as described above for the operation to be defined.
The first thing we must learn that in order for two matrices to be multiplied, they must have specific relationship in terms of their dimensions, and it is not the case that they must have identical dimension. Rather, if two matrices A and B are being multiplied with A listed first, followed by B, it will be the case that A must have the same number of the columns as B has row. The reason for this will be clear in the moment. Let's start with the beer of the symbol 2 by 2 matrix. The first matrix we have 1, 2, 3, 4, and the second matrix we have 6, 7, 8. The way we will get the product is by taking the first row of the first matrix and the first column of the second matrix and doing some multiplication. 1 by 5 is 5 and 2 by 7 is 14. Okay, 5 plus 4, 14 is 19. So that goes in that first entry for the product matrix. Now we stay in the first row of the matrix, but shift over of the second column of the other. 1 by 6 is 6 and 2 by 8 is 16. So 6 plus 16 is 22, and that will go in the second entry for the first row for this product matrix. Now we shift to the second row for of the first matrix and go back to the first column of the second matrix. So 3 by 5 is 15, 4 by 7 is 28. Okay, so 15 plus 28 is 43, so that will go in the first entry for the second row of the product matrix. And lastly we shift to the second column again. 3 by 6 is 18, 4 by 8 is 32, so 18 plus 32 is 15, and that will go in the last entry here. Thank you for listening, and I will let you with my project mate Yusuf. Thank you.
So this is another example, but the first thing we should make sure that the first row equal the first column. So we will get the first row with the first column and we will do the multiplication. So this is another example, but the first thing we should make sure that the first row equal the first column. After we do the multiplication, A and B will be 22, 28, 49, 64. There is another point that the number multiplication is commutative. It's mean like AB equal BA, but matrix multiplication is not commutative. It's mean AB doesn't equal BA. You can read here, this is like a declaration. So and this the exercise for you, you can do it, and here you can check your answer.
My name is Salim Saleh Salim. My matrix number is 291129. The presenter of the first paragraph was with you. I hope you like the presentation. Thank you for listening.
So at the conclusion that we will get the column from the first matrix and the rows from the second matrix, and the columns in A must equal the rows from B. And also if we do the transfer, that we will get another result. That's all from us. We were with you, Yusuf,